I'm going to start this video on composite functions with an example. Suppose the weight of a metal disc is a function of its area. Specifically, the weight, as a function of the area, equals the area divided by 9, where A is in square inches and W is in pounds. Now, this wouldn't be true for all metal discs. It's going to depend on how thick they are and what kind of metal they're made of, but pretend it's true for the specific kind of metal disc that we're talking about in this example. So if we know the area, how many square inches it is in size, we can calculate its weight just by taking the area divided by 9. Now the question, how much does a disc with radius 6 inches weigh? Well, wait a minute. If we knew the area, we could find the weight, but we know the radius. How can we get from the radius to the weight? Well, the weight depends on the area, which depends on the radius. Because for a circle, there's a formula that you can use to get the area as a function of the radius. It's the famous formula area equals pi r squared. So if you know r, the radius, we can calculate a, the area, by taking pi r squared. And then once we know a, we can calculate w by taking a divided by 9. So when the radius is 6, the area would be pi times 6 squared. 6 squared is 36, so 36 times pi, and since pi is approximately 3.14, when you multiply that, you get approximately 113. So the area would be about 113 square inches. Then the weight, when you take 36 pi divided by 9, you get 4 pi, which is about 12.6. So the weight would be about 12.6 pounds. So we went from a radius of 6 to an area of 36 pi, and then from an area of 36 pi to a weight of 4 pi. But instead of going in two separate steps like that, suppose we combine these two formulas into one formula that will take us directly from the radius to the weight. The area is pi r squared. So if we put pi r squared in place of a, we get that the weight is pi r squared divided by 9. So that gives you the weight directly as a function of the radius. So when we combine those two functions, those two different formulas like that, we got a composite function. So that's composition of functions. So when you have two functions, f and g, this little open circle between them is the symbol for the composition of those two functions. F composed with g. And so f composed with g of x just means f of g of x. It's the function that you give it a number for x, first it evaluates g of that x, and then it evaluates f of whatever g of x is. So to evaluate f composed with g, you're just calculating f of g of x. So you're taking the formula for f, and you're replacing x in the formula for f of x with whatever g of x is. This is a little complicated when you first encounter it, but eventually it clicks, it makes sense, and we can do it. So for f composed with g, we start with the number x, we apply g to that number so that we get g of x, and then we apply f to that number so that we get f of g of x. If you think of functions as machines that you put numbers into and get numbers out of, having a composite function like this is like when we hook two of those machines up together. So notice that I put g first. G is the inside function, which means it's the first thing that gets a hold of the number you put in for x. So whatever you input, you calculate g of that. That's the output of the g function, but that's the input then that goes into f. And then the output that we end up with is f of g of x. Now that's assuming that we do have them hooked up in this order and we're doing f of g. If we hook them up in the other order, g of f, that would also be a possibility. It would give us a different result. So now let's look at some specific examples so we can see how this works. So in this example, we're back to f of x being 3x plus 5. So f takes whatever you give it and gives you 3 times that thing plus 5. And g of x is 4x minus 1. So g takes whatever you give it and gives you 4 times that minus 1. So f composed with g, that would be f of g of x. Remember, f of anything is 3 times that anything plus 5. So here the anything is g of x. F of g of x should be 3 times g of x plus 5. So what is g of x? Well, it's 4x minus 1. So we're doing 3 times 4x minus 1 plus 5. Now we can simplify that because if we multiply out 3 times 4x minus 1, we get 12x minus 3. So we're looking at 12x minus 3 plus 5, which is 12x plus 2. So what's f composed with g of 3? Well, since we have a formula for f of g of x, we can just take that formula and put 3 in for x. 12 times 3 plus 2. Well, 12 times 3 is 36, and 36 plus 2 is 38. But we can also get this by thinking about what this does. F composed with g of 3 means first we do g of 3. G gets its hands on x, x being 3. So what does g do to 3? It multiplies it by 4 and subtracts 1. 4 times 3 minus 1 is 11. Now what comes out of g is what goes into f. We put 3 into g and got out 11. So we're going to take that 11 and put it into f. F of g of 3 means f of 11. So that would be 3 times 11 plus 5, which would be 33 plus 5, which would be 38. See how that works? Let's try another example. In this example, f of x is 2x minus 7, and g of x is 3x plus 2. So f composed with g, that means f of g of x. So remember, f of anything is 2 times that anything minus 7. Here we're taking 2 times g of x minus 7. That is 2 times 3x plus 2 minus 7. So we're replacing the x in the formula for f of x with g of x, which is 3x plus 2. We're doing to 3x plus 2 what f says to do with whatever it gets in place of x. So 2 times 3x plus 2 minus 7 is 6x plus 4 minus 7, which is 6x minus 3. Now let's try it in the other order, g composed with f of x. So that means g of f of x. G of anything is 3 times that anything plus 2. So g of f of x is 3 times f of x plus 2. And that means 3 times 2x minus 7 plus 2, which would be 6x minus 21 plus 2, which would be 6x minus 19. We could also do f composed with itself. That is f of f of x. F of anything is 2 times that anything minus 7. So here we got 2 times 2x minus 7 minus 7, which would be 4x minus 14 minus 7, which would be 4x minus 21. And what about g composed with itself? That would be g of x. G of anything is 3 times that anything plus 2. So here it's 3 times 3x plus 2 plus 2, which would be 9x plus 6 plus 2, which would be 9x plus 8. Let's try another example. In this example, f of x is the square root of x plus 4, and g of x is 1 over x. What's f composed with g? That would be f of g of x. So see if you can imagine what this looks like. Write it down if you have pencil and paper handy. Did you write down the square root of 1 over x plus 4? We just took the formula for f and we replaced x with g of x, which is 1 over x. F of anything is the square root of that anything plus 4. So f of g of x is the square root of 1 over x plus 4. And what about g composed with f? What's g of f of x? G of anything is 1 over that anything. So g of f of x is 1 over f of x. That is 1 over the square root of x plus 4. Okay, one more example. In this example, f of x is 4x minus 5, and g of x is x plus 5 divided by 4. What's f composed with g? What's f of g of x? Well, that would be 4 times g of x minus 5. That is 4 times x plus 5 over 4 minus 5. Now, when we take 4 times x plus 5 divided by 4, the 4 divided by 4 would just be 1 times x plus 5 is just x plus 5. Minus 5 would just be x. So we end up with just x. And what about g composed with f? G of f of x. G of anything is that anything plus 5 divided by 4. So here we get 4x minus 5 plus 5 divided by 4. Let's see if we can simplify that. 4x minus 5 plus 5 would just be 4x. And then 4 times x divided by 4 would just be x. Notice what's going on here. F of g of any number is just that number. And g of f of any number is just that number. That means we can start with any number for x and put it into one of these functions, take what we get out and put that into the other function, and we're back where we started. Let's try this out with a specific number. What number should we use? Pick a number. Did I hear somebody say 7? Okay. Let's try plugging 7 into g. G of 7 would be 7 plus 5 over 4, so that would be 12 over 4, which is 3. So now let's take what we got out of g and put that into f. F of 3 would be 4 times 3 minus 5, which is 12 minus 5, which is the 7 that we started with. There's nothing special about 7. One of you guys picked it. So we could do this with any number. Put any number into g, take what comes out, put it into f, we're back where we started. Or we could start by putting a number into f, take what we get, put that into g, and we're back where we started. So these functions undo one another. Whatever f does to a number, g undoes it and gets you back where you started. Whatever g does to a number, f would undo that and get you back where you started. So functions like this that undo one another are called inverses. So we can say the inverse of this function is this function, or vice versa. And that's what we're going to be talking about in the next and final section of Chapter 2.